Zoom, you guys okay?
Yep.
Alrighty, here we go. So we've got library of functions. Notice that I did give you a note about the fact that you're going to need your graphing calculator next class period. You won't need it today, so just realize that that is coming. And I told you in the videos that you would be required to have either the TI 83 or 84. If you have anything else at all, you are welcome to use it. I just can't help you on it. You and Google can become really good friends. All right, so I will help and teach through the 83 and the 84. Anything else is on you. All right, so what does that say? A how-to graph video is included at the beginning of section 2.2. If you're unfamiliar with the calculator, watch this before coming to class. I probably put that link in multiple places. I don't know if I put it in the 2.2 learn or not. Okay, I don't know if I put it there, but I guarantee you, you know how when you go into my lab on the left side, you can go to chapter 1 or chapter 2, etc. If you'll go into chapter 2, section 2. No rewind. It's where I have course notes and videos. Okay, so that tab on the left that says course notes and videos, if you go to the videos tab, if you can't find the link to what I'm talking about here, familiarity with the graphing calculator, it'll be in that list. Okay, that list is great, but it doesn't give you any due date deadlines. So that's why I don't necessarily always point you to that one. The learns always give you the deadlines. So, but anyway, so that's how you can get over there to that one if you can't find that 2.2 video. Okay, so let's just go ahead. So library of functions, rewinding a little bit, find the domain and range. We did domain and range last class period. Okay, so this isn't anything new. So let's talk about domain and range for example number 1. Okay, so remember that domain is, I gave you 2 different definitions for domain. What definitions did I give you for domain? Give me one of them. Good, X values. And then it's Becca, right? Okay, and then what's the second definition I gave you for domain? Left to right. Okay, so let's only turn our left to right brain on. If at any point in time during the next couple of seconds you think up or down, you've done it wrong. You're only thinking left to right, okay? So as I look at my graph here, what are my leftmost values? What's the very first value down on the left that you are using for this graph? Say it again. -4, okay. What about that arrow? What does that arrow mean? It's going to keep on going, right? Okay, so if my arrow means that it's going to keep on going, yeah, it does hit -4, but it goes past that, doesn't it? Okay, so let's try again. Leftmost value that's being used. -infinity. Okay. Now I'm using, here I am, I'm on the x-axis. Zoom, I know that you guys can't see me because I'm off camera, but I'm over here on the left side of the room. And I'm using x values way down here. Okay, so I'm going to start my trek from left to right. And so I'm using x values, I'm using x values, I'm using x values, I'm using x values. Do I ever take a break in using x values? Yeah. Where? Where do I take a break using my x values? Say it again, you're a little bit too quiet. Or not. 1. I take a break at the x value of 1. There's an open hole there. That's you can't touch that spot. Now, do I actually use the x value of 1? No. So what kind of a symbol should I have? Parentheses. Oh, but wait, there's more. Let's skip over the you can't touch that spot. And where do I start using x values again? It's the one thing you can't use. Okay, so I'm gonna start up at 1. Now my lab uses a union symbol here. Okay, so we're gonna start up at 1 again, and we're gonna continue our trek left to right. Do I ever take another break using X values? No, so how far do I go using X values? All the way to where? Infinity. Say that again?
You never draw that symbol.
The infinity symbol? Turn your paper sideways and draw an 8. All right, let's go to range. What are the 2 definitions that I gave you for range? Y values as well as? No, I didn't say up and down, although I know what you mean, but how did I word it? Actually the other way. Bottom to top. So I'm starting down at the bottom and I'm working my way to the top. Okay, so once again, let's look. You gotta switch your brain now. We were thinking left and right. Now we're thinking downs and ups. Okay, so you've got to be thinking downs and ups. If you're thinking left and right, change your brain. Okay, so what's the bottom value that you're using? What's the bottom value that you're using? Negative infinity again. All right, and I'm working my way up. So do I take any breaks in my Y values along the way? Where? At 2. Once again, I'm not actually using that 2. So I'll use around parentheses. Let's continue working our way up. So where do we pick up again? At 2 again, and then we're going to go all the way to positive infinity. Okay?
I have a quick question.
Yes.
In my lab, where do I find the videos that like you go over? Because apparently I didn't see them because I just went to calendar. I did all of the.
They're in the calendar.
They're in the calendar?
Yep. Now, are you talking about the PDF calendar that's inside of my addendum, or are you talking about the actual tab that says calendar?
Yeah, I went to that one and like there's the 4 links. I did all those assignments, but I didn't know there was a video. Where is the videos now?
It's either you guys have to help me because I've set it up differently for different classes. It is either going to say like 2.1 videos or it says 2.1 learn.
And that's just her thing, not like what she made.
Okay.
So like,
Pearson's videos is in the 2.1 learn, and those are optional. My videos are required. And so you say it's under 2.1 videos. It actually says 2.1 videos. Yeah. Okay.
I was just wondering where to find this because I didn't see it because I went to the calendar because I went and watched the video where you went to the My Lab again and I was confused. So I just went to the calendar and I didn't see the videos, but I'll watch them.
Yeah, yeah. They're in the calendar. They're also in the assignments. So the calendar tab and the assignments
My
tab.
assignment tab wouldn't load for some reason, so that's the reason.
Try a different browser.
And then last night I tried to go to My Lab too. I don't know if it was down, but every time I go to it, it would say error.
Try a different browser. Yeah. It is common, like multiple times per week that I switch browsers on my lab. Sometimes it'll be Google Chrome. Sometimes it'll be Firefox. Infrequently it'll be Safari. But I mean, I constantly switch browsers when it comes to my lab. If one of them's acting funky, I switch to a different browser. Okay. Yeah, that's pretty common. So. All right, so increasing, decreasing, and constant. Use intervals. We talked about interval notation, and use X values, X values, X values, X values, X values. Yeah, that's a really big deal. X values only, okay? And X values go in which direction? Left or right, okay? So again, anytime I'm dealing with those X values, I'm moving from left to right. So here we go. And example number 2, domain and range first. So let's stick with that because we're familiar with that now. We've done that a couple of times. We can move a little faster this time. So for my domain, what's the furthest value to the left? The X value that's being used. Negative infinity. Now I'm going to start my trek from left to right, start my journey, at any time, do I take a break from using X values? No, I don't. You say, yeah, but you turned a corner. Yes, I turned a corner, but I didn't take a break. I'm still using X values. So where do I stop using X values? At positive infinity. Okay. For the range, what's the bottom, go all the way down to the bottom. What's your bottom Y value that's being used? 3. Are you using that 3? What does that mean? Square bracket. And then let's start our journey up from the 3. Where do I stop using Y values? At infinity. Okay, so that gives us a review of domain and range. Now let's talk increasing, decreasing, constant. So what are the 2 rules on increasing, decreasing, and constant that you had to fill in from the video? Say it again. X values only, right? And what's the other thing? Intervals. And I don't really know what you said. I was just kind of guessing at what you said because you got to speak up. Okay, especially with a mask on, I can't read your lips. So, you know, it's terrible. You probably know somebody who's had to go into the hospital during this COVID time, and it is so difficult. They're alone. Everybody's wearing a mask. I have to tell you, this summer, it was difficult. My 94-year-old grandmother, who lives 2 miles down the street from me with my mom and dad, had to go into the hospital. She cannot hear a blessed thing. Okay, and so everybody's wearing a mask. She cannot understand anything. My mom is not allowed to be with her. She is freaking out in the hospital. It's awful, 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 awful. So all of that to say, if you're wearing a mask, I'm fine with that, but please speak up when you do say something so that I can understand what you're saying. Okay, so I have to use X values. I have to work from left to right, and I have to use intervals. Okay, so let's start back on the left. I know my domain begins at negative infinity. As I work from left to right, what is my graph doing? Is it going downhill? Is it going uphill? Or is it staying the same? It's going downhill. So we would say that my graph is decreasing from, where does it begin decreasing? Negative infinity. And where does my graph stop decreasing? No, it's not going downhill forever. At what? At -1 is where it stops going downhill. Okay, now what I say next is going to be a little strange. Okay, round bracket or square bracket? Nope, round. Round. And let me give you 2 reasons why this is round. I don't really care which reason you latch on to, but get one of these reasons in your brain and stick with it. Okay, so here's 2 reasons that you're using a round bracket. So let's say that I just had, let me go over here to some blank paper. Let's just say I have this point out in space. Is that point going anywhere? Okay. Is that point going downhill? No. Is that point going uphill? No. That point isn't even really staying constant because it's just right there. Staying constant would mean it's moving constantly, right? It's not doing anything. A point can't go anywhere. Okay, so when I come back over here, if you tried to put a square bracket on that -1, you would really only be looking at that single point. That single point is not going downhill. That single point is not going uphill. That single point is not even staying constant. That single point is just a single point. It ain't going anywhere. Okay? So that's one way to explain why I'm using a round parentheses. It's not decreasing, it's not increasing, it's not constant, that single point. It's the movement of the graph that causes it to be decreasing. Okay, that's the first way to explain it. Here's the second way to explain it. When you're doing increasing, decreasing, and constant, never, 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 never use a square bracket. Ever. You're always going to use a round parentheses, a round bracket in increasing, decreasing, and constant. Always. Okay? Hard and fast rule. All right, so one of those two, either understand the explanation or just simply memorize the rule. Okay? But you're never going to use a square bracket on increasing, decreasing, and constant. I'm still going to use square brackets in domain and range. That's fine. But in increasing, decreasing, and constant, no square brackets. Okay, so with that said, we are decreasing from negative infinity to -1. All right, so now let's go back to the graph. I'm still on my trek from left to right. I just got finished decreasing. What's my graph doing now? It's going constant. From where to where is my graph constant? Where does it start being constant?
-1.
And where does it stop being constant? 4. Again, you'll notice I use round parentheses because I'm never going to use square brackets in increasing, decreasing, and constant. And so here I am on my graph at 4. I'm continuing to work left to right. What is my graph doing now? It's increasing. From 4 to, okay. Why did you use a positive infinity and not a negative infinity? Say it again. Okay, so here's several things. Here's the first, let me make this comment. If your brain is saying it's going up, you just switched from a left to right mentality into an up and down mentality. You got to change that. Right? And that's very, very common. Is it going up? Yeah, but I don't care about that because I can only work with X values, which are lefts and rights. Okay? So I can't answer that I'm using positive infinity because it's going up. I'm going to say I'm using positive infinity because it's going to the right. Absolutely. It's going to the right. Okay? That's why I'm using positive infinity. And yes, Sierra, it is going in the positive direction. But I could say that for X's and I could say that for Y's. So it's kind of like a little bit of a muddy answer there. Like, that might be right and it might be wrong too. So, okay. So that was, did I get everything? Domain, range, intervals of increasing, decreasing, constant. Got it all. Okay. Moving on. So the things that you have to memorize for every single parent, the name, the equation, and the graph itself. And I said memorize. Okay, a lot of math is not memorization. A lot of math is you got to understand. This is one thing you just have to memorize. All right. All right. So I asked you to find the domain and the range for every single parent function. So we've got the identity. We have the graph. Okay. By the way, the 3 things you have to memorize. The name is identity. The graph is the picture. And the equation is y equals x or f of x equals x. Those are the 3 things you have to memorize for every single one. You don't have to memorize domain and range. If you have a picture, you automatically know what domain and range is. Okay, so you don't have to memorize those. Okay, so what is the domain of this line? Left to right, what values am I using? Okay, negative infinity, positive infinity. All right, now switch over to range. So from the bottom, work your way to the top. Somebody else, what's the range of this picture? Lowest point all the way up to highest? Negative infinity, positive infinity. Another way that we could say that is all real numbers. Okay, it's the same thing as saying all real numbers. All right, squaring function. Okay, domain left to right. Now, one of the things to remember about a parabola, folks, which is what this is, okay, is that in this parabola, yes, it always goes up forever and ever and ever. But what about the right and the left? What's happening right and left? Not only is it going up forever and ever, but what else is it doing, Jada? Yeah, it's getting wider and wider and wider and wider and wider. Okay, so you got to remember that. Even though I can't see it getting wider and wider, it is getting wider and wider, okay? So with that in mind then, what's the furthest x value to the left that's being used by my graph? Negative infinity. Why? Because I'm allowed to use any x value I want to all the way on the left, okay? And then what is the rightmost x value that is being used? Was this the one you got a question?
Yeah, I did it completely wrong.
Okay. That's all right. That's all right. So meta questions are just for bonuses, okay? Yeah, you're gonna get credit if they're right, but it's not gonna hurt you if you get them wrong. So that's okay. That's totally okay. Essentially, what's the purpose of an embedded question? In my mind, okay, because I don't care about bonus, honestly. I want you thinking. I want you paying attention in videos, okay? And so, yeah, you could tell me, Barney flies, and I'm gonna be like, who cares, okay? So you could fluff me an answer. I wanna know, are you thinking through this as you're watching my videos, and are you really paying attention to what I'm saying in the video? Or are you just trying to get some credit and throw some stuff down? Okay, that's really what the difference in the two things. Okay, range. So what's my bottom y value that's being used on this one? Now, Sarah, you've answered several, so you're on a break for the next few. Okay, what is it? 0. Yeah, good question. Is that a square bracket? Nobody's gonna answer it.
I put a square bracket, but the last thing that we did, you put the round one, so I've not.
Last one, as in that.
Like
Oh.
the other page, I mean, like the yeah, that thing. So that now.
Oh, so now, okay, so what's the rule? When's the only time you can't use a square bracket? Increasing, decreasing, constant. Are we working on any of those right now? Okay, so that rule is totally off the board, off the table. We're not gonna worry about that rule right this minute. Okay. Square bracket, because I'm actually using that 0. I am using that 0. And then what's my topmost y value that I'm using? Infinity. Yeah, positive infinity. Why are we using positive infinity? Because it's going where? No, this is wait, this is range because it's going up. I thought there for a minute I was asking about domain. Yeah, because this is range, it's going up forever, so that's why I'm gonna use that positive infinity. Okay, square root function. I had a student one semester call this the function that is swoop. Oh, okay. So from there, what's that? It does, doesn't it? It looks like a swoop. So, so that's the nickname for this particular graph, the square root function. All right, domain. Left to right, what's the leftmost x value that's being used? 0. And am I actually using that 0? Yes, I am. So I'm going to use the square bracket. And then what's my rightmost x value that I'm using? Positive infinity. Okay. Let's go to range. All right, down at the bottom, what's my bottommost value that's used? 0 again. And I'm using it all the way up to positive infinity. Yeah, I know that it looks like it levels off, but it doesn't level off. It is getting higher and higher and higher, really slowly, but it is getting higher and higher and higher. Think about the square root of 4. What's the square root of 4? 2. Compared to the square root of 9. Compared to the square root of 25. Right? So isn't each y value getting a little bit higher? Yeah. So it's going to continue to, it's never going to level off. It's going to continue to get higher and higher and higher. Okay. All right. Cubing function. Not Cuban, but cubing. Okay. Leftmost value. What am I using?
I can't tell if that levels off or not.
Okay. So since we can't tell if it levels off, let's use numbers. Okay. So what's a -2 cubed? -8. Now you might need a calculator for some of these. What's a -3 cubed? Negative 27. What's a negative 4 cubed? Negative 64. What's a negative 5 cubed? Negative, I know I'm really taxing your brains. I don't care if you use your calculators, it's fine. Negative 125. Okay, so is it leveling off the further out that I go? It's not. It's not. Because think about domain. I'm allowed to plug in I can plug in a negative 5. I can plug in a negative 8. I can plug in a negative 10. I can plug in a negative 1,000, right? There's no boundary on what I'm allowed to plug in. So negative infinity is my furthest x value that I'm allowed to plug in. And what's my furthest x value on the right that I'm allowed to plug in? Positive infinity. Okay, how about at the bottom? What's the lowest y value? Negative infinity. And the highest y value? Positive infinity, right? Okay. Number 5, parents. Cubed root function. Cubed root, same thing. Okay, left to right. Leftmost, negative infinity. Rightmost, positive infinity. Does this one level off down at the bottom? Yeah, same concept, same concept. If I had something like the cubed root of negative 125, that's a negative 5, okay? If I had the cubed root of 216, that's negative 6. It's gonna keep getting lower, okay? So range then from negative infinity to infinity as well. Number 6, the absolute value function, also called the V-graph. I'm sure that it's difficult to tell why somebody called it the V-graph. Maybe because it looks like a V. All right. So from left to right then, what's the furthest value to the left that's being used? And what's the furthest value over to the right that's being used? Positive infinity. Did we lose somebody or did we gain somebody? Uh-oh, Devin, what happened? Oh, she's connecting to audio. Okay, how about range? What's the bottom value on the range? 0, and I'm using it. What's the top value? Positive infinity. Hey, Devin, what happened?
I logged in on my computer.
I gotcha. Oh, you're in there twice. That's fine. That's fine. I thought we lost you there for a second. No problem. The little graphic there is just for you to look at some dance moves, all inspired by math. Okay, symmetry. So WRT means with respect to. Okay. All right. So the next few minutes, folks, it's pretty important that you understand what's going on here. In my lab, sometimes you're just asked a multiple choice question. Okay, like please tell whether the following is even, odd, or neither. Or maybe please tell whether the following has symmetry with respect to the x-axis, the y-axis, or the origin. All right, that's how it just words it in my lab. So this is a good time to talk about the test. I realize that the test is a little ways off. Help me out. Is it the 3rd or is it the 9th? I have 2 different tests and I don't remember which one it is. Okay, it's either the 3rd or the 9th. Does anybody have the calendar printed out that I told you to print out? Oh, some of you did not pay attention to my video instructions. Like not a single person? Oh, that's so sad. Zoomers, do you guys know the 3rd or the 9th? And I've got nothing. All right, so you guys are gonna have to figure it out yourself. I've given it to you in multiple places. Go figure it out. I'm not gonna hand it. I really don't know, because I can't remember if, oh, Jada has it.
It's the third.
It's the 3rd. Thank you, Jada. I appreciate that. It must be my 111 that's on the 9th. Or maybe my 215. I don't remember. Okay, so you have a test on the 3rd, okay? And so let's talk just for a minute about how we're gonna run that test. I'm gonna set up a schedule for, excuse me, those of you who test in the classroom versus those of you who test in the testing center. You will not be testing on Zoom. Well, not unless we shut the college down, okay? If we close the college down, I'll have to test on Zoom. But otherwise, 12 of you will be here in the classroom, and the other 6 of you will be over in the testing center, okay? You hear me. This is a big deal, okay? You are testing on the computer, which means if you're testing in this room, you need to have your computer and you need to make sure that you can get into Wi-Fi on this campus before the test starts. Otherwise, you're going to be freaking out. Okay? So this is, yes, I'm talking to Zoomers as well as those of you who are sitting here right now, because I haven't come up with a schedule yet. Not for the test day. Okay? So you will be testing. By the way, one of the things that I mentioned on the introductory videos, this is a bring your own device class. Okay? This is a class where you must have your computer in the classroom with you. There are days, I'm not going to ask you today, but there are days where I'm going to say, all right, folks, get out your computers right now. Let's get on my lab, and I want you to go to a specific place in my lab. You should be prepared to do that every single day of class. It's not going to happen every single day of class, but you don't know when it will and when it won't. I don't know when it will and when it won't. Okay? So you need to have Wi-Fi working on your computer on campus in this room to be able to access that test. Okay? Just out of curiosity, Sierra, when you walked down the hallway, were all of the computer labs being occupied today at 9:30?
No, there was one that I went into, but it couldn't access it for like anything for some reason.
Okay. Okay.
Yeah, I tried connecting to the Wi-Fi with my phone, and it just tells me that it's connected with no internet.
Yeah.
So I think in college's internet's messed up.
Well, the college's internet has never, this is being recorded. The college's internet has never been phenomenal. Okay. They have added in the access points to help things. Okay. So it's better than it was a couple of years ago. But if you're having a problem, folks, I'm telling you, even come to class early, not on the day of the test, but I'm talking this week. Come to class early, stay a little late, whatever, sit out in the hallway. Make sure you can get on Wi-Fi on your computer to be able to access my lab before that test day ever comes. If I had it my way, I'd send everybody to the testing center. But I'm not allowed to do that. Can you imagine if every math teacher did that? They'd kill us. Okay, I can't do that. I'm not allowed. So we have to test on a device. And by the way, you cannot test on your phone. You can't. Not an option. Okay, so it's got to be a computer. Or I wouldn't even test on the iPad personally, and I love the iPad. Okay, homework and stuff is fine. I wouldn't chance it with a test. So, all right.
The tests are on my lab math.
The tests are on my lab.
Also, I know my laptop's battery isn't the best, so it might like die or something.
So then get here fast enough to gain a seat by the outlet. And there's a few outlets on that wall. I don't know if there's any on the back wall or not. It looks like there's at least one outlet over on that wall. So there's multiple outlets in the room. Okay, so I would say get here, make sure you bring your cord, make sure it's charged or that you can at least sit by an outlet, okay? All right, so actually where I was going with this, that wasn't the intent to take quite that rabbit trail, but where I was going with this in the first place was, if I say, if my lab, and I want you to start practicing this on homework, if my lab says, tell whether the following is even, odd, or neither. Tell whether the following has y-axis symmetry, x-axis symmetry, origin symmetry. Don't just click, it's B, next, because that's not gonna fly on your test. Hear me and hear me well. Any multiple choice question on the test, the only way you can gain credit, and really this is for any question on the test, not just multiple choice, the only way you will gain credit for any answer on the test is if you have written work to back it up. So let's say you answer correctly and there's no written work. I don't care if it's correct, I'm marking it wrong. If there is no work, or if there is no work or if your work doesn't support your answer, I will not give credit. Okay?
So is this like written work that we send online?
It's written work. Well, you'll be with me. Okay, so you'll hand it in at the end. And if you're in the testing center, you'll hand it into the testing center. So yes, it'll be written work. Now, if the college closes, we'll have to do something different. You'll submit it on D2L. Okay, but let's hope we can wait on that.
Oh, you mean like a scratch piece of paper we have to turn in?
Right.
Oh, I thought you meant we had to like figure out how to write like short answer in there too.
You are not going to handwrite anything in my lab. Okay.
So basically, you're just doing like kind of like an explanation of how you know that it's work rate or work rate.
Oh.
Okay. And in Math 110, very few questions have no work. Almost every single question is going to have work. Okay, that you can show. Okay, on paper. You should always, even when you're working on your homework, should always have a piece of paper that you're writing out your work. All right, get used to that. You start getting organized with that. If I can't figure out what your organization is, I don't waste my time on it. I mean, I've got like 75 students. Okay, I don't have time to sit there and labor over what I think you might have meant to write down. Okay, all right. So on the video, I walked you through what symmetry is. Okay, how this is an even function because it has symmetry with respect to the y-axis. My y-axis is my mirror. All right. This is the big deal here to know. That's the big deal. All right, and I'll expound on that in just a minute. Symmetry with respect to the origin. Again, here's the big deal. The English version of this is I can turn it upside down and it's the same thing. Okay, so like if you take that graph on paper, I can't do it with the iPad because it just fixes itself, but if you take that graph on paper and if you turn it upside down, it's going to look exactly the same. Okay, so an upside down version that's identical to the right side up version is symmetry with respect to the origin. X-axis, not a function. Okay, so how to run the test. Again, this is all in the video, okay? How to run the test. If f of x is the same thing as f of negative x, it's automatically going to be an even function. It'll have symmetry with respect to the y-axis. Okay? If f of negative x is equal to negative f of x, it's odd, and it has symmetry with respect to the origin. Okay, now here's what I like to write on the top of my paper when I'm taking this test. Yes, I do take your test. I write down f of x, okay, that's the original, right? And then I write down f of negative x, and then I write down negative f of x. Those are the three things I write down. All right? If the first two are equal, and I'll show you how to show your work in a minute. If the first two are equal to each other, it's an even function. By the way, what kind of symmetry does an even function have? Y-axis symmetry. If the second two are equal to each other, it's an odd function. What kind of symmetry does odd have? Origin. By the way, I remember that because the O's line out, the O's match. Okay, odd and origin both start with O. Okay, and this is all I write. I don't even care if the first one is equal to the third one. Doesn't matter to me. It does not matter. Okay, so this is the test that I'm gonna write. Okay, so that's what I always write down. Now, before I talk about tests and running that test, let's just talk about visual, okay? What kind of symmetry does number 3 have? It has x-axis symmetry, right? My x-axis is my mirror. My x-axis is my mirror. What about the next one? Origin. If you turn that upside down, it looks exactly the same. So this one has origin symmetry. And then the last one. Why? Because I've already used the other two? Yeah, bad reason, right? Okay, why does this one have y-axis symmetry? Why is it even? Yes, okay, so back to the first question. Why does it have y-axis symmetry? Yeah, so it's my y-axis is my mirror there. And I like the way that Anthony just said that. He said, if this were on a piece of paper and I made a fold on the y-axis and I held it up to the light, they would line up. They would match up. So this one's got y-axis. Go back to that first one. Where would my fold on paper be if I were working it that way? On the x-axis, and the top and the bottom would line up. Okay, so that's a great way to do that as long as you have paper. Doesn't work so well on the iPad. Okay. All right, now, next, so, oh, okay, there's more down there. I started to say, where's my other questions? Here we go, example number 6. Complete the right half of the graph for this figure, part A, if my function, my graph, is odd. Okay, my function, my graph is odd. All right, so question on this one, what's the test for odd? What are the 2 things that have to be equal for my function to be odd? Go ahead and say it, November. Okay, you're correct. But that's not what I'm looking for. What are the 2 things that have to be equal? Jada? F of negative x has to be equal to, what's the other one? Negative f of x. Yeah, let's put this, I mean, that's like a whole lot of mumbo jumbo. What exactly does that mean? Okay. It means, in this case, which piece is negative? The x value is negative. Okay. On the other side, which piece is negative? The y value, right? Doesn't f of x mean y? So literally it says a negative y value. Okay. Now, negative just means opposites. Okay, don't go thinking it automatically has to be like literally negative. Negative just means opposites. Okay, so what I have pictured here is the original f of x. All right, it's the original f of x. See how it says this is the f of x in the figure. Okay, what I want to do is I want to take the original, I need it to have the opposite x value and the opposite y value. Okay, so all of the pieces of my original need to have an opposite x and an opposite y. Okay, so let's take it one at a time, okay? Let's just take some important points here. Let me zoom in. Okay, so there's the coordinate 0, 0. Let me change colors. Now, if you make that point, opposite x value and opposite y value, where do you land? At 0, 0. Okay, that one was a hard one. What is this coordinate right here? My existing f of x value, what's that coordinate? Negative 1, 1. Okay, what we're going to draw is the opposite x and the opposite y. Positive 1, negative 1, which is going to be down here. Opposite x, opposite y. Okay, and I can connect the dots with those. All right, let's go back to the original. What is this coordinate right here that I just drew? Negative 2, 0. Okay, what's the opposite x and the opposite y? Positive 2, still 0. And then I can go ahead and connect the dots. Now question, if I take this and turn it upside down, other than the colors that I used, will it look exactly the same? Yeah, it will. Okay, so this is an odd function. It has origin symmetry because I can turn it upside down and it looks exactly the same thing. Okay, now let's go to part B. Same graph. Part B says now I want the other side of the graph to make an even graph. Okay, so can you go back in your notes? What are the two things that have to be equal to have an even graph? What's my test for even? F of x, so the original has to equal f of negative x. Now, the f of x, that's just the original function, okay? But what I want it to equal is an opposite x, but same y. Do you notice how I didn't change the sign of the y value? Pause and pause. Okay, so we're taking the opposite x, but the same y. Opposite x, same y. Okay, so let's go to our graph again. I have a picture of the original. Here's 0, 0. Choose the opposite x, but the same y. Still 0, 0. Okay, what did you tell me that this coordinate up here was at the peak? Negative 1, 1. All right, give me the opposite x, but the same y. Opposite x, but the same y. So what's the opposite x piece? 1, and the same y would be 1. Okay. And then what did you say this coordinate was over here? Negative 2, 0. So opposite x, same y. Positive 2, 0. Okay, now does this match with my, hey, it looks like if my y-axis is the mirror? Yeah, it does. It does. Okay. All right, now let's talk about showing your work. See here, oh, it's bolded and it's underlined. So it's important. Okay, tell whether the following are even, odd, or neither. So again, that's kind of like multiple choice, right? But you so can't just say, oh, it's even because there's a whole bunch of even numbers up there. Bad reason. Or it's odd because I'm guessing and I don't really know. Let me tell you something else that I added to this question that is not in my lab. My questions like this, by the way, I've already started working on your test. Okay, I've already started writing it. My question in my lab, I edited the question so that it says, no graphing. No graphing. No graphing on the calculator. Okay? Because if you look at a graph, it's pretty easy to tell if it's even, odd, or neither, right? Okay? And you're going to have some of those questions too. You will have some of those. But these, it's not, I don't want you to look at a graph. I want you to show me the work. Show me the work. Okay, this is a big deal. All right, so what do we do? Well, let's remember our little test. Remember the three pieces of the test? We had f of x, and what did we compare f of x to? What was the second piece of the test? F of negative x. And if those two were equal, that's not readable. Let me fix that. If those two are the same, what do I know? Even. Y-axis symmetry. All right, what's the next piece of the test? Negative f of x. And if it's part 2 and 3, if those two are equal, what do I know? Odd, or it has origin symmetry. So this is what I'm going to use to show my work for the next piece. All right, so the first thing I'm going to do is I'm going to look at my original. Oh, well, that's easy because they wrote it down for me. See how it says f of x? It's already there. I don't have to do any work to get it. That's handed to me. Okay? The second part of the test says, see if f of x is the same thing as f of negative x. That's what we're trying to figure out. Okay? So here's the work part. I need to find what f of negative x is. All right, now tell me something. If I asked you for f of 2, by the way, we did something like this last class period. If I asked you for f of 2, what would you do? You'd plug in 2 for all the x's. If I asked you for f of Capri Sun, what would you do? You'd plug in Capri Sun for all the x's. If I asked you for f of ugly, what would you do? You'd plug in ugly for all the x's. That makes it really ugly, right? Last one. If I asked you to plug in f of negative x, you're going to put in a negative x for all the x's. Okay, so every time I see an x, I'm going to replace it with a negative x. By the way, parentheses matter here. Okay, so here we go. I have a negative 2. No work. I just copied it down. But then it says x. What am I taking the x out and replacing it with? Negative x. And what am I raising this to? 6th power. Minus an 8, just copied, times, take the x out, replace it with negative x, raise that to the 2nd power. This goes back to the discussion we had last week. Oh, help me out. Let's see here. Mary Alice, were you the one who was slapping somebody last week? Was that you?
Yes, ma'am.
Yeah, and weren't you slapping Devin?
Yeah.
Yeah, okay, good. I thought I was remembering that correctly. So this goes back to the conversation of who's close enough to slap. Okay? Remember when Devin was close enough to Mary Alice to slap, but Mackenzie was too far away, right? Okay, so let's take a look then at that very first term, the whole entire first term. Now be careful, don't just throw out an answer at me. How many negatives are in the whole entire first term? How many negatives? Okay, I hear 2. I hear 7. Oh, did we change our mind? Yeah, why is there 7? Where are we getting 7 from? Okay, so 6 of them come from here, right? There's 6 negatives here because what's directly in front of the 6th power? No, a parentheses. And everything inside the parentheses is getting slapped by that 6th power. Okay, so I've got 6 negatives here, and then I have another negative here, making a total of 7 negatives. Okay, what do 7 negatives make? A negative or a positive? A negative. How many 2s do I have? Just 1. How many x's do I have? 6, so that's x to the 6th. Okay, let's go to the next term. Count how many negatives do you have total? 3 total. And 3 negatives makes what? A negative. How many 8s do you have? Just 1, so let's write it down. And how many x's do you have? 2 x's, so that's an x squared, right? Okay, remember the test. The test said that we were supposed to compare f of x to f of negative x. If they are the same, it's even. All right, let's go compare. Look at the original and look at the cleaned up version of f of negative x. Same or not the same? Same. Good. Okay, so this is what? Even.
So they're the same because they're both negative?
No, take a look. It says negative 2x to the 6th minus 8x squared. negative 2x to the 6th minus 8x squared. Aren't they identical? Hang on. November, I'm not quite getting a positive response there.
Yeah, they're the same, but so what was the point of doing all that work if they're just the same?
They're not different. They are the same. The fact that they are the same tells me that they are even. If they were different, they would not be even. Okay, November, hang on to your question, all right? I'm thinking that maybe when I do the next example, your question might be answered, maybe. Go ahead, Dylan.
If that didn't work out, then would that mean you just have to go through
If that
each other?
If that didn't work, I have to go to the next part of the test. Oh, look at me. Do I look like I'm feeling guilty for making you do work? No. All right, let's keep on going. Let's keep on going. I'm gonna, how am I doing on time? What's that? I know, I see that. Let's go to number 9. Come back here. Go to number 9. Remember, I only do the highlighted ones. If I have extra time, I'll go back and do the unhighlighted ones. So if I have extra time, I'll go back and do number 8. What's that? It's yeah, x to the 5th. Now, this says determine symmetry with respect to the y-axis, the origin, or neither. The good thing is my test is exactly the same. The show the work part is exactly the same. Okay? So what we're going to do, what's the 3 parts of the test? What's the first piece? Compare f of x with f of negative x. So let's do that piece first. Okay? Nice thing is I already have f of x. I don't need to do anything extra with that. So f of negative x. Okay, the very first thing I see is an x. What am I going to do with that x? It's going to be a negative x. If I write it like this, have I written it correctly? I didn't write it correctly. What's the x totally getting replaced with? So then it needs to be in its own set of parentheses, because the whole x is raised to the 5th power. That means the whole negative x has to be raised to the 5th power. Okay, let's copy the minus. Let's copy the 2. What does the x get replaced with? Negative x, and I'm going to raise that to the 3rd. All right, first term. How many negs? 5. 5 negs makes what? A negative. How many x's in that first term? 5, so that's an x to the 5th. Okay, go to the second term. How many negatives in the whole entire term? 4. 4 negatives makes a positive. It's even. So I have a positive. All my negs become positive. How many 2's do I have? Just 1. How many x's do I have? Okay, so that's x cubed. All right, my test said if these guys are the same, it's an even function. They're not the same, are they? Oh dear, let's keep on testing. Okay?
Also, that's what you do, like, if it's not the same.
Bingo. Okay, which is, November, what I was hoping would answer your question. Okay?
I was supposed to say how you can get it different.
Does that make sense? Good, 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 good. All right, what's the next part of the test? Yeah, negative f of x, right? So now we need to look at these two. This one actually is pretty easy. Here's how I want you to think of this. Let me highlight it. All that is the opposite original, right? Because negative means opposite, and f of x is just the original. So all that says right there is opposite original. Every single piece of the original is opposite, okay? So there's really not a lot to show. I'm just gonna write it so that I know what I'm talking about. So opposite original is gonna be, so go back up to the original. You have to come all the way up here, okay? What's the first piece of the original opposite? Oh, not with a highlighter. Negative x to the 5th. Okay.
So he's like.
Here's the first piece of the original, make it opposite. Okay, look at the second piece of the original, make it opposite. What is it? Positive 2x to the third power. Now what you're doing, look at your test again. Compare f of negative x, that was the first thing we did work to find, to the opposite original step. Are they the same? Yeah, here's the first piece that I found. Here's the second piece I found. They are exactly the same. Okay, so what's my answer? If you answered odd, you're gonna be incorrect. Go back and read the directions. Odd's not a choice. Oh, whoopsie. Origin. It's the same work. You just have to pay attention to what you're being asked for. Okay, if it said even odd or neither, my answer would be odd. But the fact that it says y-axis origin or neither, my answer has to be origin. Okay, so go ahead, Jada.
Is x-axis symmetry the same as the origin, or there's two different things?
They're two different things. X-axis is not even a function. We're not even running a test for that.
So it's just.
Is that even
Wow.
a thing?
It is a
But
thing
we're not gonna do it.
with pictures. So we did it up here,
Yeah, that's what I was.
but we're not running any tests for it. Okay. November, did that answer your question that you had originally? Perfect. Justin? Okay. All right. Let's see. I've got number 11. Let's do number 11. 4 minutes. Oh, I don't know. Why? Because I've already done the other two?
I don't know how it looks like.
Bad reason. Let's find out. Okay, let's find out. So determine the symmetry with respect to the y-axis origin or neither. So what's the first part of my test again? F of x compared to f of negative x. Okay, I already have f of x. I don't need to do anything with that. Let's figure out f of negative x. Okay, what's the first piece? How am I going to change the first piece? Guys, don't just do mental work here. Remember the directions said show your work. You actually have to put it on paper. Okay? Negative x. Just like that. Where's my parentheses? Yeah. Minus 5 times negative x plus 2. Okay, first term. What does it become? Positive or negative? Positive, yeah, there's 4 negs. How about the middle term? Also positive 5x. Neg times neg is pos. And then what's the last term? Plus 2. There's no x's there, there's no negatives. Nothing changed with that term. All right, so we're looking at those two now. Are they the same? Oh, so what do we automatically know? Not even, not y-axis symmetry. Okay, well, I don't know yet. I haven't done the second part of the test. I can't say that yet. So what is the second part of the test? Yeah, remember opposite original. Opposite original. So let's go write the opposite original down. So what's the first term going to be in the opposite original? Negative x to the 4th. What's the second term going to be? Wait, here, look at it. It's going to be a plus 5x.
Oh, we're not looking at that one we just did.
You look at the original. It's opposite original. Yep, so go back all the way to the very beginning. Opposite original. Okay, and then the next piece, what's the opposite of the last term? Yep, minus 2. Okay, so we already figured out that the original and my first guy, they're not the same, so it's not even. And now I'm looking at this guy with my newest, and what do you see there? They're not the same. So not only is it not even, it's also not odd or origin, so this is a neither.
So they're both not the original.
Okay, does that make sense? All right, folks, it's 10:50. Keep up with your stuff, okay? All those due dates in my lab. If you have questions, let me know.
I didn't really understand what you were asking with this. Like, I didn't understand what I'm supposed to do with it. It's like I heard what you said on the video, but like it still didn't really make sense what I'm supposed to do.
I have it. There it is.
Oh, you're just okay.
See what
I
works and what doesn't.
I was really confused. I thought I was supposed to like
Oh,
take
gotcha.
a function
Yeah,
and put
no.
it in there or
No.
something. I didn't really know what that was.
Yeah. Does that make sense?
Yeah, I got it now.
Sorry, Blake, am I on your way? I want to meet the dog too, so.
So Thursday, I'm supposed to be virtual for this class.
Okay,
But I have to be here at 11, whatever, for my next class. So,
yeah,
So I'll be in the car part of the time.
that's fine.
So I just need to pay attention.
Yeah. Yep, just like those screen buddies are doing.
Okay.
Yeah. Yep. I would love to tell you that we could do something different, but
Yeah,
there's just not the option.
I was just
Yeah.
asking you.
Yep. Thanks for asking. Appreciate it. Okay, so who do we have here? Who's joining our class?